All right, so now we're going to talk about an application for linear functions. And one of the applications of a linear function is for a projectile and the velocity of a projectile. So what we have here, this is the general form. This is actually the slope-intercept form, the slope-intercept form of a linear function. So this is the equation of a line solved for y, and we replace y with f of x. And what that means is that we know that we are inputting an x value, this is the independent variable, and um, when we input an x value, the independent variable, it's going to spit out a y value for us. So the y value is spit out is actually this entire symbol, the f of x. This here, f is just the name of the function. All right. So this is the form that we put lines in, slope-intercept forms, so that we can look at them as functions of x. So basically, the independent variable on the right-hand side is x. That's the only variable. M and b are just numbers. And if you remember from the other work you've done with lines, m is the slope, and b is the y value at the y-intercept. All right, so one application of this kind of function is a velocity function for something that is free falling. So when something is in free fall, the only force that's acting on it is the force of gravity. So let's take a look at the parts of this function. Well, the speed that something is traveling at when it's free falling is actually a function of how long it has been falling. So that's what is indicated with this notation here. You see the independent variable here is t, which is time. This is the time that the object has been in free fall. And v stands for velocity. And velocity is related to speed. Speed doesn't have a direction. So if you're going 50 miles per hour, it doesn't matter what direction you're going 50 miles per hour. Velocity, you have to add the direction. So for instance, if we're talking about a projectile, what we're really concerned with is how far it's falling to the earth. And that being said, if you look at be up as being positive and down as being negative, when something is falling toward the earth, its velocity would be negative, which is why there's a negative acceleration here, negative acceleration due to gravity here. And that's actually what the g is here. G is the acceleration of the object due to gravity. Acceleration due to gravity. So, oops. So g, like I said, is the acceleration of the object due to gravity. And that changes depending on how close to the center of the earth you are, or your elevation. But this is at sea level. All right, and this v naught right here, v naught, we call it v sub 0, is the initial velocity. Initial velocity. It's literally the velocity of the object at time 0. If you notice, if you plug 0 in for the time, if the time is equal to 0, 0 minutes after the thing is starting to free fall, or 0 seconds after the thing starts to free fall, then this term goes away, and all you get is v sub 0, v naught. It's literally the velocity at time 0. So these are all the players. We have the velocity at time t is the v of t. It's the output. T, time, is the input. You put in the time in seconds or whatever units you want to measure in. G is the acceleration of an object, how fast an object accelerates due to gravity. And T once again is time, and V naught is the initial velocity, how fast the object is traveling at time 0. Let's take a look at a problem. So it says an object is launched and is now in free fall. So we have an object that's launched from somewhere and is now falling. Um, and the only force acting on it now is the force of gravity. 2 seconds after being launched, the object's velocity is negative 24 feet per second. Once again, this is negative, meaning that the object is falling towards the Earth. That's why the velocity is negative. Remember, velocity and speed are not the same thing exactly. Velocity also has a direction. This negative tells me I'm going in the negative y direction towards the center of the Earth. All right, 3 seconds after launch, the object's velocity is negative 56 feet per second. And it says find an equation that relates the velocity of the object to the time it has been falling. Well, once again, we're looking at this thing, and what this symbol is telling me is that time is the independent variable, or the first coordinate in my ordered pair, and velocity, or speed with a direction, is the second component in my ordered pair. So what I have here is I have two ordered pairs. It says 2 seconds. 2 seconds is a time. And my ordered pairs are going to consist of times 2 seconds after launch. It is negative 24 feet per second for the velocity. So negative 24 feet per second is the velocity. My ordered pairs are going to be time versus velocity. So let's make those ordered pairs. The first time is 2 seconds, and the first velocity that's related to that time is negative 24. So here I have a relationship between a time and a velocity. That's my first relationship. Another relationship, or a part of the same relationship actually, because it's the same object, is 3 seconds after. So when time is equal to 3 seconds, this thing is going negative 56 feet per second. So negative 56 is my velocity. So I have those two ordered pairs. Basically, I have 2 points, and I need to come up with the linear function that describes or models these 2 points. So let's go ahead and do that. As a matter of fact, since this is the velocity function, let's grab it, and we'll use this to create our model. And remember, this is no different than mx plus b. M would be negative g, x would be t, and b would be v naught. So this is just a linear expression. That's all we have here, a function that's defined as a linear expression of t. So let's plug everything in here. The first thing I see here is this first ordered pair tells me that the v of 2, when the time is equal to 2, the velocity is equal to negative 24. But also, when the time is equal to 2, the velocity is negative g times 2 plus v naught. So I'm using these two things to create this equation. The ordered pair where t is equal to 2 and v is equal to negative 24 gives me t is 2 and v is negative 24. But that's also equal to the expression here when you plug 2 in. So I get this first equation with the two unknowns, g and v naught. All right, since I have two equations, or since I have two unknowns, I'm going to need a second equation. Luckily, there's a second point here. So let's take a look at that point. That says that the velocity at time 3 seconds is equal to negative 56 feet per second. This is also equal to negative g times 3 plus v naught. So I get two equations with two unknowns here, a system of equations actually. So let's go ahead and clean them up. Let's simplify these a little bit, these expressions. So my first equation is that negative 24 is equal to, this is going to be negative 2g, and then we have plus v naught, And then secondly, we have negative 56 is equal to negative 3g, and then we have here plus v naught also. So here I have a system with two unknowns, g and v naught, and I also have two equations, so I can either use substitution or elimination to solve them. Now, What I'm going to do here is I am just going to use substitution. So I'm going to take this first equation and I'm going to solve it for V naught. If I add 2g to both sides, I will get V naught is equal to 2g minus 24. And I'm going to take that and I'm going to plug it in for V naught in my second equation. So I'm going to have negative 56, negative 56 is equal to negative 3g, and then I just found out that plus V naught is actually plus uh, 2g minus 24, because that's the value I just got for V naught from the first equation. All right, so I can simplify this. Now I have one equation with only g unknown. So let's see, we have um, negative 56 is equal to negative 3g plus 2g is just negative g minus 24. And when I add 24 to both sides, I get plus 24 here, plus 24 here. I get negative 32 is equal to negative g, in which case I see that g is equal to 32. G is acceleration due to gravity, and indeed G is 32 feet per second squared. So once I found G, I can use that value of G to find the value of V naught. V naught is equal to 2G minus 24 is what this red equation says. V naught is equal to 2G minus 24. So that says that V naught is equal to 2 times 32 minus 24. 2 times 32 is 64 minus 24. So I have here that the initial velocity, the speed at which this thing was launched, was 40 feet per second. 40 feet per second. So now I can come up with my equation. Remember, my equation that I was looking for was of this form. V naught times negative gt plus, or sorry, V of t is equal to negative g naught t, sorry, V of t is equal to negative gt plus V naught. So I found G and I found V naught. I can plug them in, and then I will have my model that models the velocity of this object at any given time. All right, so let's see here. We have this equation, and we found that we can realize some of these things. V of t then is equal to negative g, remember g was 32, times t plus v naught, which is 40. So here you have it. This is a model or an equation that relates the time that the object has been falling to its velocity at that certain time. If you wanted to figure out how fast it was going 5 seconds after it was launched, you just find the v of 5 and so forth.